All right, hey Ajay. So this is a weird problem. I don't think it's really well. A lot of times with this type of problem, you make approximations that aren't valid, but they're close. So we're saying that the height at any point in time is equal to this equation. And it's an equation that's in the form of y equals ax squared plus bx plus c, except instead of x, we have t squared and t. B is now equal to v, and they say in the problem that v is our initial velocity. They also said that v equals the initial velocity equals 17. Not that we really care, but that means that she went off the jump at 17 feet per second. She went horizontally at 17 feet per second. But that's her velocity, her initial velocity. We also know that she is the bottom of the base is at 0 and the top of the base is at 12. So that's really our y-intercept. So we know that c equals 12. Now we can fill that stuff into the formula that's up here, and we can say h equals minus 16 t squared plus 17 for our initial velocity, t plus 12 for her initial height, or if you want, even the y-intercept. So this is our equation. So question number 1 wants us to put that in there for our initial equation. Question number 2 says if she lands 5 feet above the base, that means h equals 5. So now we've plugged in, instead of h, 5, and we write out the rest of the equation. We have a quadratic equation. This is a quadratic equation with one variable, t, and we should be able to solve that. And you know that you can solve that. You might be able to factor it. You might be able to complete the square to solve it. You might have to use the quadratic formula to solve it. I'll remind you of the quadratic formula that you have to commit to memory at some point. The quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's one way you could solve this equation. You'd have to set it equal to 0 first. So that is that. And then you should think about question number 3. So that's a way to solve question number 2. Question number 3 is saying, what do you think would happen if she goes faster? If her initial velocity is bigger? What's that going to do to her time? One thing you could do is you could say, well, let me plug in a bigger number, because here you already solved for t here. So then let's say you make that into 20. What happens to her time to get back to a height of 5. And if you plug in a higher number and you get a higher number, then you know it's going to take her longer to get to 5. And if you plug in a higher number for the velocity and it takes less time, then you know that it takes less time. So hopefully that helps, and let me know if it doesn't, and I can send you another video. All right, Ajay.